everyone, and this is the final week of this 8-week series. So let's get into it. So what we're going to do today is substitution. So many people send encrypted messages through text. And the reason for this is they don't want to risk people capturing their messages while being sent and learning valuable information. As a result, the goal of this project is to create a key provided from the user and convert some plain text into a ciphertext. So let's look at an example. So as you can see here, we have our key, where all of our A values will become J, all of our B values will become T, all of our C values would become R, and so on. So basically what we're going to do is first ask the user for the key, then we'll ask them for a plain text. And based on that key, we're going to individually change each and every character, such as H would become, I believe, V, which is right here, and we'd basically print that out. So now pause the video and try to figure this out. So as you can see here, we have our code where we're first going to get our key from the user and then the plain text, which we eventually convert into ciphertext. So the first thing we should probably do is make a function called def substitution, and then we'll probably need two parameters. First would be key, and the second would be plain text. So key and then plain text. Now let's call this function in the main function. So substitution, key, comma, plain text. Perfect. Now, how would we approach this problem? Well, one way we could do this is loop through each and every character of our plain text using a for loop as seen below. We could do that and then basically check what is the value of character. If character is equal to, let's say, A, actually let's do lowercase a first. If it's equal to A, then what we're going to do is first we have to create a ciphertext, which will be a string, and inside of that we're going to add our items, our letters. So we would do that. If character equals A, we would do key index 0 dot lower, and we would add this value into ciphertext. So it'd be ciphertext equals ciphertext plus key index 0 dot lowercase. Then we would copy this code. Now we would do it for B. So let's do that. This time would be elif, and we would make this lowercase b, then 1. Then let's copy it again. Perfect. And we would make it C. Then we would make it index 2. And then eventually we would get all the way to lowercase z. And then we would have to add conditions for character is equal to uppercase A. And then what we have to do is ciphertext equals ciphertext plus key index 0 again, but this time it's going to be dot upper. And as you can see, this process is going to be taking a long time, and you probably have around 52 if conditions. Now, is this optimal? Keep in mind that you never want to repeat your code like this. And obviously it's not optimal. So now let's come up with a solution. So a thing about characters such as A or B is that in binary code they're made of zeros and ones. So each of these have a specific ASCII code, which I'm going to show here. So as you can see here, a lowercase a has an ASCII code of 97, and between A to Z we have an ASCII code from 97 to 122. And then for uppercase A to uppercase Z, we have an ASCII code from 65 all the way to 90. So based on this, we can program our code to be much more optimal. So the first thing is, obviously, we're going to have our for loop for each of the characters. And then we're also going to need an if condition. So now pause the video right now and try to brainstorm what this if condition could be. Okay, so now let's get started. So the if condition is most likely going to be if character is less than or equal to uppercase A and character is less than or equal to uppercase Z, then what we can do is character minus 65. Now you might say, why minus 65? Well, 65 is the first letter. It represents the uppercase A, and if we have, let's say, an uppercase A, we do 65 minus 65, we'll get 0. And we would basically use that number 0 to access a specific index in our key. However, we have to understand, character is basically a string, such as, let's say, this quotation marks and uppercase A. Can we subtract an integer from a string? Well, the obvious answer is no. So what we have to do is use a Python library called ord and then type in character, which will give us the ASCII code to the character value. And then what we're going to store that inside of is a variable such as index, and then we'll access that index in the key. So we'll say key index dot upper, because we want all of our characters to be uppercase in this scenario. And then we'll do ciphertext is equal to ciphertext plus key index dot upper. Then we would have another elif condition, and in this case we're going to do as character is less than or equal to lowercase a, and character is less than or equal to lowercase z. And we're going to do basically the same code as above, where we'll have index is equal to ord character. However, we'll do minus 97. Why 97? Well, the first letter is for 97 for the ASCII code. Therefore, if we have a lowercase b, we'll have it as 98 minus 97. That would get us 1. And we would access the index 1, which would be the second item in the list, as it should be. And what we're going to do is ciphertext equals ciphertext plus key index dot lower this time, because all of these characters are lowercase. And now, let's say, what if they're neither of these? They're a space, or maybe they're a, let's say, exclamation mark or a question mark. So in that case, we'll just have an else condition, and we'll do ciphertext is equal to ciphertext plus character. That's all. So now let's do a practice example. So let me first reload this, just write some blah blah blah. Obviously it's not going to work. Now let's run the actual code. So we'll enter key and we'll do uppercase hello. As you can see, nothing prints. Now why is that? Well, we've added everything to ciphertext. However, what we forgot was that we have to print ciphertext. So do that, print ciphertext. Now let's do this again. Hello. Strange. Now it's printing E, EH, EHB, EHBB, EHBBQ. Now why is this? Well, the reasoning for this is that our print ciphertext is inside of the loop. As a result, after every iteration, it's printing whatever is being stored inside of ciphertext. Now how do we get rid of this? Well, we unindent and basically indicate that it is outside of the for loop. So let's run it again. Hello. And as you can see, we get EHBBQ. You can review the code that we have here and make sure that is the message we're supposed to get. But I can tell you it is correct. Now let's do another example. Let's do hello world. So there's our key, and we'll do uppercase H, lowercase everything else, some commas and some space. And as you can see, we get an uppercase J, the space and the comma is still there. And all of the lowercase characters here are also lowercase in the ciphertext. However, an issue is that all we're saying is JRSB. Like, what is that? So to make it much more clear for the user is we'll make a formatted string. So we'll do F and then ciphertext, and then we'll print out our ciphertext variable, which we would put inside of the braces. So now let's run it. So we'll do hello world, and as you can see, we get ciphertext, and that is our ciphertext. So I hope you guys enjoyed this video, and I'm very grateful for you guys supporting these videos that I have posted, and this is the last week of 8. See you guys in the next one.